Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps in the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so the value of the 5 in this number, you need to be considering the place value. Think of your place value grid. We've got units, tenths, hundreds. 5 is in the hundreds column, so it's 5 hundredths. Next one, I've got 4. If I take one away, I've got 3. If I add 2, I end up with 5. So I've got 5y. Okay, so nearest 10,000. If it helps, write that down so you can actually see it. 10,000 has 4 zeros. So we're going to put those 4 zeros under this number. That tells me my kind of cutting point, which is here. Is it 5 or more? Yes. So I'm going to add 1 to this side, giving me 68. And then add in all those zeros. Factors of 40. This is where we do factor bugs in class. So this is what you might recognize. Do them in pairs because then it's easy to see what goes together to make that 40. So 1 times 40, 2 times 20, and then just go through in turn so you don't miss any off. Is it in the 3s? No. Is it in the 4s? Yes. Is it in the 5s? Yes. Is it in the 6? No. 7? Nope. No. And you've already gone into like a repeat mode. And once you start repeating, you know you've found them all. So then just list them out. Okay, so quite a wordy question, lots of information. So read through it very carefully is my advice, and then start just breaking it down, doing it bit by bit. So we've got the information of her costs. She wants to hire the room for 4 hours. So if we look at this information, hiring of the room is £36 per hour. She wants it for 4, so 4 times 36. You've got 28 people at the party and she's charging them £15 each, which means she's going to get £420. Her total costs are the food, the drink, and the hiring. We can see that the cost is coming out at 423 and she's only getting in 420. So will she get enough money to pay everything? No. You have got that question mark. Make sure you're answering the question. Okay, when you toss a coin, you have 2 outcomes, heads or tails. So the probability of getting a tail is 1 out of your 2 outcomes. So the cross is going at a half. What's the probability of getting a 7 on a 6-sided dice? That would be 0 because it only goes up to 6. 3 yellow sweets and 1 blue sweet in a bag. That means that there are 4 sweets in the bag. So your total is 4. He's taking a random sweet. What's the probability it will be blue? Well, there's only 1 out of those 4. So the fraction is a quarter, which places us here on the scale. Okay, now sadly, the graph hasn't kind of reprinted itself very well here. So these lines aren't as easy to follow as they will be in the real GCSE. We're being asked to show the information that we've been given here on the actual scatter graph. So they've given us rainfall at 6.1. So this is our rainfall. So we would go to 6.1 and then 32 umbrellas sold. So we would go to 32 and we would mark that on. Next, we're being asked what type of correlation it is. So the answer to that is positive. If your crosses have this sort of upward trend, then it's always positive. If the crosses were going down, then it would be negative. Now, part C, Mr. Wither sold 40 umbrellas. Estimate the rainfall for February. So we're going to use the graph. They expect that that 2 marker is part of your method. And we put on a line of best fit. Now, your line of best fit is a straight line that goes all the way through, and you need to do your best to kind of split it in half. I always think of it as a magnet to the crosses. You kind of want the crosses drawn as close, kind of pulling towards that line so that you have an even number either side. Once you're happy with that, then you would go to your 40 mark, come across, hit the line, and then you would come straight down and read off what you've got. So I would say that I am about 7.2, 7.3. The result that is acceptable for your answer is 6.6 to 7.6. That's because everybody's line of best fit is likely to be slightly different. So they allow for that here. You could still get full marks without this line if you still show this. Show that you're using your graph and you're not just kind of giving a lucky guess. Otherwise, you won't get it. Okay, so we're being asked to reflect in the y-axis. So you can see that the y is here, which means it's this line. There's various methods. You can count in, count out. And on vertical and horizontal lines, that's probably the easiest way to do it. You can use your tracing paper, where you pop your tracing paper over your shape, trace your shape, trace your line, give it a good kind of marker, maybe go across here and put the cross on so that when you flip it over, you can line it up. Tracing paper is so good when you have to reflect in a diagonal line, and I would thoroughly recommend that over the count if you're not very visual. So we're going to count here. I'm going 1, 2 in, so 1, 2 out. counting into that Y and then away from that Y. So these are all my points, and then I just draw my triangle to finish the question. Okay, part B is asking us to draw an enlargement with the scale factor 3. Now that means everything is going to be 3 times bigger. So my base of 4 will become a base of 12. 4 3s are 12. We would have 6, 9. And then when it comes to this one, don't overthink it. In fact, don't even worry about the calculation there, because our shape is just going to join together. And here I'm just joining that diagonal. As I said, don't need to even think about it much because it's the last line going in. It's just going to work. You can draw that anywhere on the grid. I mean, you haven't got a lot of options because it takes up most of the space, but if yours is in a slightly different position to mine, that is absolutely fine. Okay, so we've got a small sack and a large sack, and the difference between the two is 15 kilograms. Now, you can draw the little sacks if you think having something like that will help you. What we're going to do is say that the total 65 and one has to be 15 kilograms greater. We're going to take the 15 off, which will give us 50. And then we're going to divide through by 2. So we're going to share out what's left. That puts 25 in each. So I've got 25 in this one, and I've got 25 in this one. The 15 that I took off, I will add into the larger one because I want that difference of 15. And that will give me 40 and 25. I can then double check that the difference works. These add to 65, so that works. What's the weight of the smaller sack? And the answer would be 25 kilograms. Okay, now this is a strange question. We've got EDEXCEL practice papers, and what I think happened, certainly maybe in the early days, I don't know, is they weren't checked, double checked. You know, they're very careful with real GCSE papers. You can't put a paper out with errors, but I am seeing the odd error in these practice papers. We are told the equation is this, and then her working starts on a completely different equation. Now, what mistake did she make? You could have written, well, she's copied her equation down wrong, which I couldn't agree more, given that these are different. And if you're assuming the question is given to you correctly, then that is very valid. And if you wrote that down, that's absolutely fine. I think that is a mistake by EDEXCEL personally on the practice paper, because the real mistake is here where she's added 3 instead of taking 3 away. So here you've got an add 3. In the method, you would take away 3 to give you 6, and we've got 12. So you can see they added by accident. So that's what I would be writing on the bottom line. But like I say, if you made a comment on this being different to this, well, why not? It is. So we've got to work out the cost of hiring the car in euros. Now we have a fact right there. When you have a fact, you can put them side by side, pop in the labels, and produce this kind of little grid. And then the third piece of information, which has been given to us in pounds, can go in the pounds column here. And this is my boxes and labels method, which works in so many places. And you may not need it here, but I'm just demonstrating and showing because this is the type of thing that we do in class. We multiply on the diagonal, we divide in the corner by the trap number here. Now, dividing by 1 isn't going to change anything, so I can go straight into just a 620 divided by 1.25. Your calculator gives 775 as the answer. Okay, so part B is asking us to work out the difference between the cost of the perfumes, and we need to give our answer in pounds. The exchange rate is the same, so I'm going to set that back up. I need to be doing this in pounds, so I'm going to change my euros into pounds. So I'm going to be putting 50 in the euros column, multiplying the diagonal, divide in the corner. 50 times 1 is 50, so it's just 50 divided by 1.25, which gives us 40. 42, take away 40 is 2, and that is our answer. The difference is £2. Okay, so the information in bold is key to answering the question. Each day, every third customer gets a mystery prize, and each day, every 20th customer gets free postage and packaging. So on Tuesday, the bookshop had 150 customers. How many of them got a mystery prize? Well, 1 in 3 did. So we just need to divide through by 3. How many of the 150 got free postage and packaging? Well, again, 1 in 20 did. So we're just going to divide through by 20, which gives 7.5. So it's an integer answer, 7 people. Okay, so how many of the 150 customers got a mystery prize and the free postage? So thinking about the mystery prize, if it's every 3, then the third person did, the 6th, the 9th, the 12th, and so on. Basically, the 3 times table are our people getting the mystery prize. What we want to do is consider that 3 times table at the same time as considering the 20 times table. So the 20th person got free postage, the 40th did, the 60th did. Now, it doesn't take us much to see all those customers that got the free postage. So we might as well just carry on and list them all out. Now, which ones are divisible by 3? This one is divisible by 3. And this one is divisible by 3. So there are only 2 that get both. Okay, we've got a table with information about the number of students and the number of teachers on each of 4 days. We're being told that for every 12 students at the sports day, there must be at least 1 teacher to help. So on which of the days will there be enough teachers to help the sports day? So we're going to take Tuesdays, 179 students, and divide through by the teachers. This gives us 14.91. So this is saying I need 14.9 teachers. Well, that means I'm going to need 15, and I have 15. So tick, I can definitely run the sports day on Tuesday. And then I'm going to repeat this and compare. So I need 13.5, which means I need 14 because I can't get 0.5 of a person. I need 14. I've only got 13. Wednesday isn't going to work. I'm going to work out Thursday and Friday. And then I can compare. So here is telling me I would need 14.1. So I have got 14, but I actually need more than 14. I need 15 and I don't have that. So that's a no. And then the last one, I need 11.9. So that means I need 12. I have 12. So Friday works as well. So just making it clear, Tuesday or Friday. Okay, we're being told that 30% of a number is 120. So 30% is equal to 120. I would like to know what the original number was. Now, this is a fact at the end of the day. So I could set it up using my grid. I want 100%. Multiply the diagonal and divide through. Throw the whole thing in your calculator and you get 400. Now, I'm only demoing it this way. Obviously, there are other ways to think that through and process that problem. Okay, I love a show that. It means that we already know what we want the answer to be. So you're going to work this out just like you would if they hadn't given you this bit, but you know if it's going wrong because your answer has to match. Now, there are obviously various different ways to do this. I'm just going to do the smashed window method. Now, the smashed window looks like this, and we put our fractions along the top and down the side, but I don't actually have fractions, I have mixed numbers. So my first job is to sort that out. The way that I do this is I look at my denominator, times that in to the whole number, and then I add on my numerator. So for the first one, I've got 2 times 7 is 14, add on the 1, 15 over 2, and then we're going to be taking away 12, 13, 14 over 3. So we'll set that up, and then we just multiply in. This is always my denominator. And then in this order, I either add or take away. So I've got 45, take away 28, which gives me 17. Now 6's into 17 go 2, with 5 left over the 6. Okay, so we have got to work out where in this rectangle the third wind turbine can be put. Now, what's important is that it's 100 meters from both A and B. Within the information, we have been given this fact here, that 1 centimeter represents 20 meters in the real world. Remember how I love a fact. So I've got 1 centimeter representing 20 meters, and I need to be 100 meters from the wind turbines. So I multiply across and divide. Multiplying by 1 doesn't do anything at all. So we're doing 100 divided by 20 to work out that 5 centimeters is the key distance that I want to be from both A and B. I'm going to get my compass, and I'm going to stab the compass on my ruler at 0, stretch the arms so that there is a distance of 5 centimeters for my pencil is on the 5 centimeter, and my stab is at 0. So I've got the distance at 5. And then I literally stab the compass, be really careful not to move those arms at all. And then you will just scoop around, and you will produce something a bit like that. Mine isn't accurate because I don't have the tools, but you will produce a curved line. And what we're saying is that we are 5 centimeters at this point, we're 5 centimeters at this point, we're 5 centimeters at this point. We can see that that is further than that. So my sketch isn't brilliant. But if I'm going to be 100 meters away, I need to be this side of the line. So this is the region from A. But I do need to do it from B as well. So I pop that one on. Exactly the same method. And this would be my region here. So that's what I'm shading. And that's what it should look like. Okay, so Mr. Handy is painting the lines for the netball court, and we've got to work out the total length of all of the lines. So we can see here the length is 30.5 meters, and we've got 2 of those. And then we can see this length of 15.25. There is 1, 2, 3, 4 of those. And that also gives 61. We've then got our semicircles. So this could be joined to this to make a full circle. So I want the circumference of a circle. If I go to my formula sheet, it will tell me to use pi d or 2 pi r. Now we have the radius given to us here, so we could use this one for ease. 2 times pi times 4.9 gives me 30.787, and on it goes. So the total for both of these together is 30.787. I'm just going to add those up and then check in with what they want for the answer. It wants it correct to the nearest meter. So that would be 153 meters. Okay, now, if you are being asked to draw a graph on a calculator paper, use your calculator. It's what it's there for. If you don't know, then you're going to have to do everything by hand. By hand, you'd be taking your 3 times x minus 2, and you would be substituting in your x values, which you have been given here. So when x is 3, you do 3 times 3, take 2, which is 7. So when x is 3, y is 7. And you would repeat that. You would keep going, put in the 2, put in the 1, generate the coordinates, and then you'll be able to draw your line. But if you have learned how to use your calculator to do this, you will just enter in your equation that you've been given here. You will set up your table range, and it will produce all those coordinates for you, which is what I have done. So I'm going to plot the rest of the coordinates and draw in the line. So Abby is 5 years older than Kathy, and Bhavna is twice as old as Abby. So if I knew Abby's age, I'd know Bhavna's age. And if I knew Kathy's age, I'd know Abby's age. Kathy's the problem here. If I knew Kathy, I'd know everybody else. This is algebra, and it's not obvious. If I knew Kathy's age, well, I don't. So I am going to assign her x. That's a number I don't know. It's Kathy's age. And then I can express everybody else's. So Abby is 5 years older. So it's Kathy's age plus 5 more years. And Bhavna is twice as old as Abby. So I need to double Abby's. So 2 lots of the x and 2 lots of the 5. The total of their ages is less than 30. So I really need to clock that less than. Now the total of their ages using the expressions is 4x plus 15. But I now know that that is a number less than 30. I'm going to go on and solve this equation or this inequality that I've written. So I know that x is less than 3.75. I've got to work out Bhavna's greatest possible age and give my answer as a whole number of years. So I've got 2 times my x, and then I've got to add 10. That gives me 17.5. I've got to give my answer as a whole number. I'm in the world of less than. So the answer is 17. Now, you may have taken this down to 3 and used 3 here. If you did, it would have given you a result of 16. That is an acceptable answer on the mark scheme. So if you did that 2 times 3 plus 10, you would still be correct. Okay, we're going to draw a pie chart. First thing we need are the angles that we need to measure. And this is the maths bit, okay? And you can't draw a pie chart without the maths bit. So first thing we're going to do is add up and find out just how many birds there are in the frequency. That gives us a total of 72. So I have got to fit 72 birds into my pie chart. I have 360 degrees to play with. I'm going to share that out with all the birds and see that they're all going to get 5 degrees each. Well, I'm obviously not going to measure 5 degrees 72 times. What I am going to do, though, is say that my magpies, I've got 15. If I times that through by 5, they would take a total chunk of 75 degrees. I'm going to repeat that on all of my birds. And then I'm going to go to the pie chart and I'm going to draw those sizes in. Now, they've already done the first one for us and they've labeled it. So it's really important that we kind of clock the labeling and make sure that we also label. You would use your protractor on this line so that you can create the next section, which would be a 50-degree angle. Once you had drawn that 50 degrees in, I would really recommend labeling it up, showing that you were drawing a 50 degrees. So if you are slightly off, you are still showing you knew what you were doing, and then putting that label in. And then with each new section, you line up on the most recent line that you drew, okay? Now, I don't have a protractor with the software that I am using, which is a real shame, actually, because it would be nice to demonstrate this really clearly. So this line for that section, this line for the next section, okay? So I have given an impression of what your final answer should look like, which is this, all labeled up, all sectioned out very accurately. Okay, so we've got red and blue pens. There are 12 red pens in the box. The probability of taking a random blue pen is 2/3. That means that to take a red, it would be 1/3. And we kind of need to make that connection so that we can then connect our number of pens, 12, to the probability of 1/3. If a 12 is worth 1/3, if we double, then 24 would be worth 2/3. If we add another 12 on, 36 would be worth 3/3, which is our whole, which is everything in the box. So the answer is 36. So we've got some information about a water meter. There's quite a lot going on, so we've got to make sure we keep checking in with this. If you don't have a water meter, it's just 107 per year. So there's no maths here. It's just there to help us compare. So Henry uses an average of 180 litres of water each day. But if we look in our box, we've got information about how much he has to pay a year. We're comparing it with what he pays for a year. So we're going to have to work this up into a year. So we're going to times our 180 by 365. And that's what he's going to get per year. We don't want to stay in litres. Now, the reason we don't want to stay in litres is because they're going to be charging us for cubic meters. So I now need to use this bit here, divide through by 1,000, so that I've got my cubic meters. Now I can multiply this through. However, you can either use this or you can convert at this stage to your pounds. It's really down to what feels comfortable to you. I'm actually going to change it now. So I'm going to just divide through by 100 so that I can just get myself into pounds as early as possible. That's a personal preference though. Now that gives me 59.93. I've also got to remember to add on my charge. If I miss that, even though I can kind of see already it's going to stay under that 107, I've still got to show it. So that's my total cost for getting it via the water meter. And I can see that he should very much have a water meter. If we read that last line, should Henry have a water meter? That's a question we have to answer. And it is yes. Okay, we've got to write the nth term. So we're going to be looking at the gaps. It's going up 7. Just double check it is doing that every time. And then you have got 7n. So the gap number is the number you always put with your n. Now we're just going to go back 7 places to see what we get here. 3 take 7 is -4. That is what we pop on the end of our nth term. So 7n minus 4 is the final answer. We're being asked, is 150 a term of this sequence? Well, we're not going to carry this sequence on to find out because that just wouldn't be efficient and would most likely go wrong at some stage anyway. What we're going to do is set our 7n n minus 4 to equal 150. If this is in this sequence, our n will be a whole number. So we're just going to solve the equation. I'm going to add 4 to get 7n equals 154. I'm going to divide through by 7, which gives me n equals 22. It's a whole number, so yes, 150 is in the sequence. You can write more. You could say n is an integer, so yes, 150 is in the sequence, but ultimately this shows it, and you've shown with your yes, you understand what you've done. Okay, so we've been given a lot of information. It is actually really wordy, isn't it? Which is quite off-putting. Just try and pick out the key information. So in 2015, patients weighted 11% less than in 2014. I got a percentage and they're talking about something reducing. So I've got a decrease. So I know this is my original times multiplier equals result. We know that in 2015, it was 68 minutes. And it says that in 2015, patients waited 11% less time than in 2014. And obviously, we don't know that 2014. So there's an original amount in 2014 that we don't know. It got multiplied by 0.89. That is our multiplier for a decrease. And it gave the result of 68. So to finish this off, we will just divide through by 0.89, which is 76.404, and on it goes. So to the nearest minute, we have 76 minutes. The hospital has a target to reduce the average time patients wait to be treated in the accident and emergency department to 60 minutes in the next year. And we've got to work out that decrease from 68 to 60. Now, the formula for this one is the difference over the original. So the difference between 68 and 60 is 8, and the original is obviously 68. But that's a fraction. We want to write this as a percentage, so we would times through by 100. That gives us 11.764. So 11.8 would be a good degree of accuracy in that question. Okay, with this type of question, I would absolutely 100% recommend drawing what they're talking about. It will be so much easier. So we've got square A, and then we've got square B. It does say that square B is twice the length of square A. So let's just give it some dimensions. Let's say that A is 2, so B would be 4. Get a feel by actually creating the situation they're describing. So the area of A would be 4. The area of B would be 16. This is not double. So once you've got a feel for what's going on, you just want to be able to put this into a sentence. You've got your diagrams backing up everything that you're about to write about. So that will make it easier to communicate everything across to that examiner. So we've got the communication really clear there. And that counter example, which is the approach we've taken here, is probably the easiest way to do it. Okay, last question. Now, this is quite tricky. If it's something that you don't really feel confident with, maybe you haven't seen it before, I have linked a how-to video just to provide a little bit of support. And then that method just talks you through a little bit slower, a little bit easier to follow, hopefully, if you've not seen it before. So that's linked here now. Otherwise, what you would be doing is clocking that it's a quadratic. I know it's a quadratic because of the power 2. To solve a quadratic, we factorize, and quadratics factorize into 2 brackets. So I've got my brackets down. I drop the x. I do the signs. It starts positive, so it's repeated exactly how it looks in the question. I then take the last term and I look at what multiplies to make it. So 2 times 5 makes it. I then look at my middle term. I want to make a 3. A 2 and a 5 will help me make a 3. 5 take away 2 makes positive 3, and it is a positive 3 that I need. So it will be 5 take 2. This equals 0 still. And now I've written an equivalent form for this equation. I want each one of these brackets to equal 0. So we are going to say x is equal to minus 5. If I had minus 5 here, minus 5 plus 5 is 0. Perfect. And then x is equal to 2, because 2 take 2 is 0. And those are my answers. Okay, I hope you found this practice paper helpful with your revision and your preparation. We are creating these papers all the time, getting them done as quickly as we can and posted onto the channel. If you like what we're doing, please like and subscribe. If you have any comments, please do talk to us, and hopefully I'll see you in another video.